Welcome back, Physics 30. This is the second part of the initial booklet for Unit 4, Electric Current and Potential Difference. So this is Booklet A Part 2 video to go along with it. And I left you with a couple of questions here dealing with electric current. We'll take a look at these. What is the current through a light bulb when it takes 24 seconds for 18 coulombs of charge to pass through its filament? So we know we're looking for the current, we know how many charges flow through there and the time in which that happens. So just simply using the formula as is, 0.75 coulombs per second or 0.75 amps. C, how much charge passes through a starter motor if it takes 4 seconds to start a car if there's 225 amps of current during this time? So we know current, we're asked to find Q, the number of charges, and T we also know. Now you'll notice here 225 amps, I converted to 225 coulombs per second, just to make sure that the units work out nicely when I rearrange the formula. So I'm looking for Q divided by T, so I'm going to multiply each side by T. Q will equal I times T, and you can see with my number with these units, when current is expressed in terms of coulombs per second, you can see how the seconds cancel out, and I'm left with coulombs. 2 sig figs, so 900, that middle zero is significant. Okay, a couple more questions here. Small electric motor draws 0.4 amps of current. How long will it take for 8 coulombs of charge to pass through it? So again, I know what current is. I'm going to change it to coulombs per second, just so my units will work out nicely. The charge is 8 coulombs, and I'm looking for time. I is equal to Q over T, so if I interchange I and T, I'll have T isolated. So T is equal to Q over I. 8.0 coulombs divided by 0.40 coulombs per second. The coulombs cancel, seconds flip up to the top. 20 seconds is my answer. There's 2 sig figs, so I need to ensure that that zero is significant. E, how many electrons pass through a light bulb in each second if the light bulb has a current of 0.5 amps? So I know the current, I know the time, I need to find out the charge that's flowing through here. So I is equal to Q over T. I'm looking for Q though, so multiply each side by T and I get that. 0.5, and again, put current in terms of coulombs per second. Seconds cancel out, I'm left with coulombs. But the question further asks, how many electrons is this? So technically, this charge represents electrons. So looking back at the formula earlier in the booklet, Q equals NE, or looking for N, Q over E. This is technically a minus 0.50 coulombs because it represents electrons. The elementary charge of an electron is negative 1.6 times 10 to the minus 19 coulombs. And when I figure that out, the negatives, of course, cancel, the coulombs cancel, and I'm left with 3.1 times 10 to the 18. And I can slap the word electrons on the end of it, because that is the elementary charge that I'm dealing with. Okay. The final vocab here, elementary charge, the charge of a single electron or proton. So depending upon whether I'm talking about a proton or electron, determines whether I use a positive or negative sign for that. Its value 1.60 times 10 to the minus 19 coulombs. And electric current, we can just view it as the movement of electrons in a conductor. So we're looking at here, this is just the sideways view of a wire. Electrons moving in one direction can constitute an electric current. Okay, so the big idea here is that to measure the charge of an object, we have to get a bundle of charges to make it measurable. And again, it's a huge amount. We take 6.24 times 10 to the 18 electrons or protons to represent something, and that bundle of charge is called a coulomb. Okay, so there you have it. That's the first booklet done. We'll see you soon.